All right, here we go. This is our last section of Chapter 7 on proportional lengths. Before we get started, I'm home. I'm wearing my fluffy flannel pajamas because it's cold outside, and that surely is distracting to some of you, and I apologize greatly. But we will persevere. Let's jump straight to this. This is pretty related to some stuff we did in previous sections, but let's see how it works. If a line parallel to one side of a triangle intersects the other two sides, then it divides them proportionally, okay? And it creates similar triangles. All right, parallel line. This may remind you of a midsegment. I hope it does, because the midsegment was also parallel to the third side, but this is not, G is not a midpoint, H is not a midpoint, or at least not necessarily. So it will be slightly different. What this means is, there's another name for this. It's called the side splitter theorem. I'll refer to that frequently because it splits the sides into two different pieces. So we got these pieces, DG and GH, and we got DH and HF. What the side splitter theorem means is that DG, this part of this side, over GE, this part of this side, equals DH, this part of the other side, over HF, this part of the other side. Sometimes that's an easier proportion to write than the other one that we talked about in the previous section. We can write this a different way. We can also say DG over DH, this side, this part of this side over DH, this part of the other side, equals the remaining parts, GE over HF. You have to be consistent. Been the name of the game so far. We can also consider the entirety of those sides. DE is the entirety of this side, DF is the entirety of this side, and we can write proportions with that as well. So DG over DE, the part over the whole, equals the other part over the whole, the consistent part, of course. We can also throw this in here, DG over DH equals DE over DF, or GE over HF. Any pieces and parts of that you desire will work. So there's lots of options when we're talking about these sides being split. GE over DE equals HF over DF, this part as well. Okay? Let's go look at this example down here. Example 1, find the value of x. So we have parallel lines chopping a side, two sides into different pieces. It's parallel to the third side, so we can use this theorem. X is the entirety, 5 is this part, or 15 is this part. So what is this little part that's remaining? X minus 15 would be the answer. This other side over here, we got 20 and 8, so that means 28 is the entirety. So we can solve this a bunch of different ways. Let's first use the specific theorem here, side splitter. So if I break these things out, it's a whole lot easier to see. 15, this would be the similar triangle way of doing things, like what we would have done in the other section. We could say 15 over x equals 20 over 28. You could have done that differently, and it still worked. You can actually reduce more. For some reason I didn't. But you solve and you get 21x, or 21 is equal to x. A different way we could have done this would have been to use the parts. We could have said 15 over x minus 15, this part over this part, equals 20 over 8. This is really the side splitter theorem at work. You get 21 here as well. So you got options when you have two sides split up by a parallel line. So as we look at number 1 down here, look at all these ways we could set this up. We could say that we have this x and this 33, of course, make x plus 33, that entire side. 27 and 18 make 45. So we can use 33 over x plus 33 equals what? See if you can fill in that proportion. Equals 27 over 45. Or we could have set it up with 33 over x. This part over x equals 27 over 18. Or we could have used the smaller part down here over the whole equals the smaller part over the whole. Any of these would have worked. Reciprocals, change the means, extremes, however you want to set those, it will work. The key is consistency. Go ahead and solve those whichever way you chose, and see if you can do 2, 3, 4, 5, 6 as well. I trust that you've paused and done your best right here. I definitely should see some work on these. All right, the second of 3 parts of this section. Do you remember where we had the parallel lines that would break up into congruent pieces? Well, that's great and all when it breaks up into congruent pieces, but if you have parallel lines with transversals and they're not congruent pieces, like this 16 is not congruent to 4 here, of course, well, it creates proportions. Okay? If 3 or more parallel lines intersect 2 or more transversals, then they divide the transversals proportionally. I think this is the most straightforward part of this, maybe even the whole chapter. Because check it out. What this means is, in this example, if we have these 2 transversals, those pieces make a proportion. 25 minus x over x equals 16 over 4. You could have switched the order around a couple different ways, but just look at the proportion that it gives you and use it. Okay? So you solve it, you get x. Go ahead and try it. I think you can do it. Oh, before you do, here. I assume you're listening right now and others aren't. They're just copying stuff down. Do not copy down x over 15 equals 12 over 12.5. We'll see if anybody falls into this trap. But solve 7, 8, and 9 if you haven't done so already. Pause the video and I'll show the answers in a second. Those are some answers. All right, finally, this last theorem of the chapter has nothing to do with similarity, but it has everything to do with proportions, which is why it gets thrown in here. The triangle angle bisector theorem. If an angle of a triangle is bisected, check out what happens. If any ray or segment or anything bisects an angle of a triangle, then it divides the opposite sides into segments proportional to the other 2 sides. Okay? I think this is easier to see in action than it is with those words. Let's see what we mean by this. All right, we have an angle bisector, right? These angles congruent, that is a bisector. What that means is this piece, x, and then this piece, which we kind of need to figure out what that is. Yep, if the whole part's 40, that's 40 minus x. It's in proportion with the other 2 sides. So x and 40 minus x is in proportion with 27 over 45. I chose to write it this way. X over x minus 40 equals 27 over 45. Or we could have written it this way. X over 27 equals 40 minus x over 45. The key is it's this part and this part is in proportion with these parts. However, which way you write it, as hopefully you've picked up by now, there's tons of ways to write these proportions. It doesn't matter to me. Just do it correctly. So I solve for x here. I get 15. If you want to be the best math student, and I mean, of course you do, you'll always, when you solve for a variable, plug it back in and see if it makes sense. So if x is 15, then we have 15 and 25 over here. How does that make sense? Well, 15 plus 25 equals 40, of course, but does it divide it into proportions? Well, yes, it does. Okay? So 25 over 27 equals 25, or 15 over 27 equals 25 over 45. They both reduce down to 5/9, which means that they are proportional. See if you can figure out 10, 11, and 12. Go for it. Pause. Answers. I hope this makes some sense. This is the end of Chapter 7. Of course, that means, well, we'll be reviewing soon, but get some rest because we've got tests coming up around the corner. Bye-bye.